What's up, everyone? The title of this problem is Prepend and Append. It is from Codeforces, and here's what it says. Timur initially had a binary string S, possibly of length 0. He performed the following operation several, possibly 0 times. Add 0 to one end of the string and 1 to the other end of the string. For example, starting from the string 1011, you can obtain either 010111 or this other string, which is like the opposite of this addition. You are given Timur's final string. What is the length of the shortest possible string he could have started with? A binary string is a string, possibly the empty string, whose characters are either 0 or 1. Input. The first line of the input contains an integer t, the number of test cases. The first line of each test case contains an integer n, the length of Timur's final string. The second line of each test case contains a string S of length n, consisting of characters 0 or 1, denoting the final string. Output. For each test case, output a single non-negative integer, the shortest possible length of Timur's original string. Note that Timur's original string could have been empty, in which case you should output 0. Alright then, so let's look at a couple of sample inputs in order to make sense of this. And to be honest, at first I didn't really understand it. Maybe I just had to um, read a bit more carefully because it says that we are looking for the shortest possible length of Timur's original string. So we are given like the final one. So it said that this the original string. Um, Sorry, I'm not making any sense. So yeah, let's just look at the sample inputs. So for example, on the first sample, on this sample input, we get 9 test cases, and the first one is going to have a length of 3, and that's going to be the length of our final string. Now, I want you to think about this. This is our input, and this has to be our output, meaning 1. Why is that the case? Well, if you think about it, the initial string could have been 0. So why is it not 0 uh, every time if we are looking for the shortest possible time? Now you might be thinking that doesn't make any sense, but to me it kinda did. So that was until I looked at this a bit more closely. And think about it. For example, here we have the final string, which is 1, 0, 0. And we have one very important constraint, and that is that whatever our initial string was, we have to add um, either 1 or 0 at the beginning and end respectively, or vice versa, uh, 0, 1. Um, but we have to add two characters or two numbers at a time. We cannot only like add, for example, a 0 at the end and that's it. No, we have to add the two characters at the time, or append rather. So that leaves us like this. So for example, if this being our final string, in order to sort of like reverse engineer how we got here, we would have to start looking at the outer uh, borders, so to speak. I don't know if borders is the right word, but at the outer values, meaning in this case the rightmost value and the leftmost value, uh, so that we can determine whether as we as we get closer to the center of the string, if this was performed like it is described on the problem. And what do I mean by this? For example, take this. Let me jump into the editor. Let's say you have this, right? You have a string of length 3. So now this is the final one, all right? So you have to find the initial. Let's just imagine, for example, that the initial is empty, that it is just 0. Why that cannot be? We know for a fact that that's not true because on the sample input it says that the initial length will be 1. But why is that the case? Because if you think about it, if we start out empty and we start adding either 1 or 0 or 0, 1, there's like no way we can end up with this string. How that makes sense? Because that's like the key idea. There's like no way. So what we have to do is start from the outer sides of this string and start checking. Let's see. Okay, so we have our left side and our right side, and we have to determine because this is a binary string, like there's like only two possible values, 1 or 0. So we can say something like, or we can do something like, if the rightmost is equals to the leftmost side, then that means this was part of an operation that we perform in from from the beginning, meaning this was an alteration, so to speak. So, if that was the case, we can continue looking more at the center of the string, in this case here, and then there's like only one value left, and in this case we can conclude that that's like our initial string because there's no other um, yeah, because there's like the only value left. Otherwise, as explained, if these were eliminated, there would be no way to end up with the final string. Um, I think that was not great explanation, but hopefully it'll make sense with the code. So let's just do that. So let's see. Um, we are we're given the length of the final string like this, and we're given the final string final s, right? So just like this. And now we have to create a point of or 2 points of reference. The first one would be our right side or our rightmost item in the string, which we can obtain. And if you can think of the string as an array, for example, so the last item, meaning the rightmost item, will be you could get something like n because n is the length of the final string, and you can subtract one from it because the array will be zero based. And then for the left one, it would just be zero because that's where where it all all begins. And anyways, um, then you don't have to do this necessarily, but I like to do it. I'm just going to create a variable called ans, short for answer, and this will be initially of value n. Why is that? Because this will be tracking how of our length changes as we get to know the string. You'll see what I mean in a minute. Then we can begin iterating. Now, what are we iterating, or in what way are we iterating exactly? Well, if you think about it, we can iterate in a two pointers kind of way, in which as long as our right side index, so to speak, is larger than the left side, we can keep decreasing our right side and increasing our left side. And so in that way, we can, at each iteration, compare whether the current pair, so to speak, was introduced as a part of the of a change like this, like explained here. So, for example, what constitutes that? Well, it would have to be the two or the two items, the right one and the left one, would have to be different because that's the constraint explained here. They would they in the moment they are both the same, they are both zero or they are both one. That's when we know we have found our initial string because that's the moment when we know that these transformations have stopped. How that makes sense? So how do we do that? Well, it's pretty simple. We say while right is larger than left, we can do this. And then let's check for the condition because we would have to stop this. Otherwise it could get messy. So just let's just say if final s uh, right is equal to, oops, that's not it. Final s right is equal to finals s left. We could just break this. Could just break this loop. Otherwise, we could take our current answer, which is initially the length of the final string, and we can subtract 2 from it. Why is that? Because that it's like we are subtracting to, yeah, I mean the length of 2 because that would be either the 1 or 0 we injected either at the beginning or the end. And then we would have to, for the right side, we would have to decrease this value by 1 in order to keep iterating over the string. On the left side, we would have to increase it by 1, just like that. And then after this, we can just output the answer. So let's test this. Here we have 1, 2, 5, 0, 1, 2, 5, 0, 3, 1, 0, 3, 1, 0, 2, 4. Great. So it's looking acceptable so far. So let's give this a go. All right. And it's accepted, right? Okay, perfect. So the time complexity per case of this would technically be something like uh, n of divided by 2 because we are sort of like iterating the string like 2 items at a time. So it would take half the time if we would just be iterating, let's say, from left to right. But because the constants are not taken into account, we can just declare this O of n, and that's it. So hope that was somewhat useful, and that's it.